So good morning, guys, and welcome back to another round of Steel Connect webinar. And I'm Rocky, and your host today to talk about steel and building related topics. Today's topic will be about common influence of seawater, swimming pool, and glove factories on buildings. So, of course, it will cover seawater, that means ocean, swimming pool, what goes into the water, as well as one of the processes of the glove factories. So what do you think all these have in common, right? So to give you a brief overview, all of these activities or so-called processes, or even the nature, contains what we call chlorine or chloride ions. So chlorine, as better known, is called chlorine gas, right? But there is actually another term called chloride, which is basically in another form of chlorine gas. Okay, so chlorine gas in nature is almost non-existent because they tend to react with other substances like metals or other minerals. So the most abundant form of chlorine is actually in terms of a chloride ion, and it is called sodium chloride. So sodium chloride is a very scientific term, but for you and me, normal person, right, we call them salt. Basically, your kitchen salt, table salt, rock salt, whatever we call it. So it is sodium chloride. And to explain how this salt came about, or how chlorine will influence your building through this salt, let me just give you a background of how salt was formed. Right. So it actually before human civilization, when the nature was in its own cycle. So we have this phenomena called hydrosphere. So hydrosphere, if you have seen, I believe most of you have seen this diagram where it shows you how the water gets recirculated in nature, right? So of course, this one seems like there are a lot of wording and so on. So let me just simplify it for you, okay, for this purpose. So imagine you have a mountain and the ocean, right? So these are the two most basic, landscape of Earth, right? And you have also the sun. So when the sun shines onto the ocean, so water tends to evaporate and form clouds. And this cloud will move inland and started, saturating and form what we call rain. And this rain itself will be collected in the nooks and crannies of the inland mountains, hills, and so on, and hence forming lakes and rivers. And as the water percolates through the mountains or rivers or stones, it actually started collecting or dissolving, the minerals that are contained inside all these rocks and so on. And typically, all these waters will dissolve minerals, right? And by dissolving the minerals, it actually form salt. And salt is being brought into the ocean by river, the vehicle of river. So when it reached the ocean, what happened is that this cycle will still keeps on going. The hydrosphere cycle will keeps on going. So where water gets evaporated and start bringing in all the minerals that are from the inland, and hence that's why you will see seawater is much more saltier than fresh water. So to give you a bit of context of how salty seawater is compared to fresh water or drinking water, let me just give you a bit of context. Drinking water normally contains less than 1 gram of salt within per liter of water, and for seawater it contains 35 grams of salt per liter of water. Okay, it's because of this natural phenomena that salt water is one of the most severe or pervasive element to human basically buildings. And that brings us to our first point of seawater. And to tell you about seawater's influence on building, let me just give you an idea. Some oceans, they will actually bring out what we call sea spray. That means small particulate of seawater that are brought up by the sea wind or sea breeze. And all these sea spray will actually carry salt particles that will basically deposit onto any surfaces. And just to give you an idea, this is basically me walking down a beach, and you can see my spectacles actually started, to have all these micro deposits of sea spray. And of course, on the building, then you can see it from all these small dots of white dots. Right. So basically, all this sea spray will settle on, and the water will get evaporated. But what's left will be the salt particles. Okay, and basically, it virtually will just settle on any surfaces. And over time, all these salt particles will actually start reacting with any types of metal that it can settle on. Okay. So to share with you how salt actually or sodium chloride actually affects metal. One of the characteristics of salt is called hygroscopic. Okay, so where salt itself, just like curing meat or curing drying vegetables, they actually absorb moisture out of the substance. So same thing, salt settling onto building surface, they actually absorb a lot of moisture, and especially if let's say the environment itself is very humid, such as environment in say Malaysia, then the salt itself will constantly absorb the moisture from the humid air, and hence allowing for the salt surface or salted surface to form what we call electrolyte. And this electrolyte itself is basically a medium where it will actually promote what we call galvanic reaction. So in the context of coated steel, this electrolyte or salted surface will actually promote reaction between the steel as well as whatever is protecting it, which is the galvanic coating. Okay. And of course, not just roofing that will be affected. Some other components that are more vulnerable to this seawater will actually fail first. So of course, in order to prevent these vulnerable areas being showing failure, then you actually need to have a proper selection or design that can actually minimize the this salty effect. All right. So one of the potential failure mode would be the fasteners. So if the building is located near the sea, so one of the tendency is that salt will settle onto all these fasteners, and sometimes if you notice, fasteners will be one of the first one to actually fail, because the coating that is on top might not be sufficient to actually protect the fastener. So one of the byproduct, as you can see from this diagram, is that it will actually show some kind of white deposits, which indicates that the fasteners are starting to fail. Okay, and to eliminate this, one of the options that are available or widely available out there is actually to use a conceal fix profile. Okay, so this eliminates any types of external fastening, and hence eliminating the side of fastener failure on the outside. And of course, another thing that's another surfaces or areas where seawater or salt particles will condense on or settle on would be the cut edges. So cut edges can appear onto the end of the cladding or roofing sheets, as well as where the fasteners are, because when you drill a hole, then there will be a cut edge over there. So these areas, if let's say allow salt particles to deposit or accumulate, then it will also show sign of accelerated corrosion, okay, just like what's shown here. So one of the very crucial thing about preventing cut edges would be to choose a more durable material. Of course, today we won't cover what are the materials that are available, but this is the point where you have to look for a material that can be durable in the environment. materials that can last or has been proven to last in the same environment, meaning sea near the seawater, for more than 5 years or even 10 years. Okay, so by doing so, you are able to prevent any types of premature deterioration, especially on the cut edges, you know, on your building, or on your cladding. And another effect of seawater that is lesser known or observed less would be the unwashed area. So just now I mentioned that sea water or the salt particles will accumulate onto virtually any surfaces, including the ones that are facing downward. Okay, because the particles are so small, and at the time that sea spray was sprayed on, it was actually moist, right? So it can actually settle onto any surface and dry over there and settle. Okay, so for the unwashed area is basically areas that are not washed naturally by rainwater. Okay, so the effect of this is that there will be actually build up of all these salt particles on this unwashed area. So here you can see one of the effects of long-term exposure of sea breeze on the unwashed area, where you can see white spots, right, just like the fasteners, right? And this will eventually cause deterioration faster. So the way to prevent deterioration of due to seawater on unwashed area would be to have a periodic wash down on this unwashed area. So the point of doing so is actually to prevent or to reduce the salt build-up that are on these areas. So by doing so, you minimize or reduces the salt accumulation. And yeah, so that is the first point. So of course, but let me just show you one of the environment. It's called swimming pool. Okay, so this is our second point. So what is the similarity between swimming pool and seawater? Okay, so they both need to have a disinfectant that remove all these unwanted bacteria from infecting cross infection. Okay, infecting from one person to another person. So for swimming pool, we know that there will be random strangers swimming in the pool. So it actually requires cleaning through different types of disinfectant. And no surprise, the most common chemical that is used to disinfect swimming pool would be chlorine or chloride ions. Okay, so how this ion actually works is actually, just now I mentioned this chlorine gas is actually toxic, but one of the most use case for this chlorine or chloride ion is water treatment. So be it the water treatment center that treats your water as drinking water, or swimming pool, it actually kills all these microorganisms or bacteria. Okay, so for swimming pool, these are the three common chemicals that is used. So chlorine gas, or even sodium hypochlorous, or calcium hypochlorous. Okay, and they can exist in either liquid form or tablet form. And of course, by throwing all these liquid or tablet, they actually have a measurement to how much you need to throw in, add into the swimming pool to actually kill the bacteria, or have sufficient chemicals to kill the bacteria. And just to share with you, one of the example, sodium hypochlorous mixing with water, this is a chemical reaction. Sodium hypochlorous mixed with water will actually generate this product called hypochlorous acid. Okay, and this is the chemical that is used to kill bacteria. And don't worry, this is termed as acid. Is actually not going to harm you on your skin once you dive in. But what happens is that it will actually kill the bacteria that is on you or on other person, to stop it from transmitting into other people in the pool. So this term hypochlorous is also can be referred to as free chlorine. Okay, meaning there will be this free chlorine itself will be the term that I will be using later on, okay, to ease your understanding. So for swimming pool, if let's say the pool has been cleaned you might have or notice there is a distinct smell, right, of pool. And also, have you ever wondered why you should actually shower before entering the pool? Okay, so it's actually very important for you to shower to remove all the sweat from your pool, because the sweat, or so-called human perspiration, like sweat or urine, can actually react with this free chlorine. And one of the byproducts of this reaction will be called chloramine. Okay, so meaning reaction of this hydrochloric acid with the amino acid that is ammonia that is emitted from our sweat and urine. So this is the chemical that will cause the smell that you observe, when you go to a swimming pool. Okay, and sometimes it can be very strong to a point where you don't want to swim. Right, so this is a legit concern, because this chloramine is the one that is the culprit that will cause corrosion. Okay, and it will be worse if, let's say, more people are in the pool. Okay, because more people are in the pool, meaning there will be more chloramine generated from this pool. Okay, and this chloramine itself is known to accelerate metal corrosion, even for stainless steel, and is a known problem, especially for indoor pools. Okay. So over the when I did this research, indoor swimming pools encountered various types of abrasive environment, and it is all mainly due to this chloramine compound, or chloramine gas. Okay, and this indoor pool, how it actually make it worse is that when this chloramine is generated when people jump into the pool, the chloramine will not be able to escape freely by natural ventilation. And in fact, if let's say there is any indoor HVAC system, right, then there's a potential of this chloramine going in and being recirculated into the building as well. So increasing the concentration of chloramine in the pool. And this has actually was confirmed to cause one of the a fatal case in Switzerland. So it was actually back in 1985, where one of the swimming pool in Switzerland actually had their concrete roof, also called concrete ceiling, suspended by stainless steel, collapsed and killing 12 people in the pool. And it was actually found due to the collapse was actually due to the cause of stainless steel rod failure. And the failure mode was called stress corrosion cracking. And it was found due to the exposure of this stainless steel to the chloramine chemicals. So, of course, if let's say stainless steel is going to corrode, and no exception to other types of metals. So, to prevent or minimize the effect of chloramines, there are a few ways you can actually approach this, okay, where you can also combine all of them together. So for the first, for cladding, right, then you need to actually provide additional what we call non-reactive barrier below the roofing sheets. So by doing so, it will actually minimize exposure of the roofing sheets to this chloramine, and of course, on the long run, you can actually provide a longer term building lifespan for the swimming pool. Okay. So of course, another more effective way, or more obvious way, is actually to have the building designed to provide sufficient ventilation. So I'm not talking about just HVAC. HVAC, sometimes you need to consider whether the chloramine will be recirculated, like I mentioned earlier. But another way is actually look at some of our aquatic centers. So the pool itself is an open air swimming pool, and you can have natural airflow, air ventilation to carry out or carry away the chloramine from the pool, right? So this will actually prevent build up of these chloramine chemicals within the indoor pool. And last but not least, you should also conduct scheduled inspection and maintenance. So if let's say you own a swimming pool in your bungalow, or indoor pool and so on, then you should actually observe or carry out inspection on periodic basis. I would recommend 6 months, 1 year, to make sure that there is no corrosion happening onto some of the components. I'm not just talking about main structure. I'm talking also about sometimes you have sound systems, right, that is locked down by bolts, stainless steel bolts, or so on. Those areas could be hidden away, but those areas could have a catastrophic failure if, let's say, it is failing. Okay, so do conduct a scheduled inspection for your building and all the accessories. Going into our last point, let me just share with you glove factories. Of course, we know that now glove factory is quite famous because of our pandemic, and they're churning out more gloves to actually save life and also prevent any infection or cross infection. So there are actually a lot of different types of gloves, and we're talking about disposable gloves now. And all these gloves typically would have a very similar production process. Okay, and to allow for one of the process is actually to allow for donning or doffing of gloves, and meaning putting on or taking off gloves. Okay, this is the term they use, donning and doffing. And this process is what we call chlorination process. So no surprise, it is containing chlorine. Okay, so the main concern for this chlorination process is that it will actually have a really huge chlorine tank filled with chlorinated water. Okay, where the gloves, after is formed on the former, it will actually be dipped into this chlorinated water to allow for this feature of easy wearing and taking off of the glove. Okay, and of course, to give you a bit of context, this chlorine tank itself is containing exponentially higher chlorine concentration compared to swimming pool. So give you a context, swimming pool itself can have around 2 to 4 ppm of free chlorine inside the water. Okay, but as compared to chlorination tank, it will contain at around 1000 ppm of chlorine inside the chlorine tank. So it shows you how much of the chlorine is actually contained in this chlorine tank. And because of this, sometimes the chlorine could escape from this tank and cause internal environment to be very corrosive. So it is not just corrosive to the building. Sometimes can be harmful to the exposure level could be harmful to the people working inside. Okay, so the chlorine tank itself is also normally located on the highest floor. Okay, so this will actually affect how the building performs actually. Okay, chlorine tank located on the highest floor, and it operates 24 hours normally. Okay, based on these two factors, what will happen is that if, let's say, the process is running at night, and this will actually cause more detrimental effect onto the building. The reason why is because imagine this: the chlorine tank is on the top floor, and when it's operating at night, the external temperature will be lower compared to the internal temperature, and internally there will be high humidity because of all these tanks of water allowed to evaporate and so on. So the reverse side of the roofing sheets will actually have prevalent internal condensation. Okay, and this condensation itself will allow chlorine to readily condense onto the roof side of the roofing sheets and start causing corrosion. So here I show you one diagram where we observe some sign of internal condensation on the roof side of the roofing sheet for glove factories. Okay, so this can actually be detrimental to not just roofing sheets, but also the structure like C purlins or I-beams and so on, if, let's say, they are not well protected. Okay, so to actually prevent or prolong the building or the roofing, to prevent this sign from happening soon, one of the ways is actually very similar to swimming pool, to include additional non-reactive barrier. Okay, so non-reactive barrier can also mean include sealing that will not allow reaction with the chlorine components. Okay. And of course, aside from that, the building itself can also facilitate for a taller top floor, so that it allows for better ventilation. Okay. So we know that just now normally the chlorination process will be located on the top floor because of the nature of the process. Okay. So one of the ways is that you can actually design the ceiling for the top floor to be higher so that it allows for better airflow and ventilation to reduce the concentration of chlorine to one spot. Okay. And of course, because of the high concentration of chlorine for chlorination tank compared to swimming pool, perhaps instead of natural air ventilation, you can also introduce what you call mechanical exhaust systems to actually ventilate out by suction of all these chlorine gases. Of course, if let's say the suction is escaped to the external environment, it will also cause a long-term durability for not just your building but nearby your building. So perhaps there is also existing solution where you can actually vent it out to scrubbing systems where it will neutralize all these corrosive substances. Okay, so all in all, for glove factories, the chlorine concentration in the building is very high, where our recommendation or what we observe will be to actually introduce a mechanical exhaust systems that carry it into a scrubbing system to neutralize this corrosive effect. Okay, so today what we covered here is first seawater. So how seawater actually affects your building because of the content of sodium chloride contained in the seawater. Right. So to prevent the build-up of seawater, of course, first you have to look at whether your building design have any vulnerable areas, like for example fasteners. Right. If there is, then perhaps you should consider some kind of profile that eliminates external fastening. And also on the unwashed areas, perhaps you should consider washing down the salt particles on a periodic basis. And for the second point of swimming pool, what we covered is that is needed for disinfectant to disinfect the pool, right? And in the process, it will actually generate this thing called hypochlorous acid that will react with sweat, or when people jump into a pool, they will react with the sweat or urine, and forming what we call chloramine, which is corrosive to the best of the steel, which is stainless steel. And to do or to prevent or minimize the effect of this chloramine on the building material, then natural ventilation needs to come in. And of course, if your roofing sheets can introduce an additional non-reactive barrier, then that would be excellent. And last, we talk about glove factories, which is more corrosive compared to the swimming pool because of its high chlorine concentration. And to actually minimize the effect, of course, I presented or show you a few options, where the first one is actually to provide a better ventilation to the tank by mechanical exhaust, right? And of course, the same method of showing a non-reactive barrier is also possible, right, to prolong the roofing sheets. And last, if let's say you want to have better overall environment, perhaps introduce scrubbing systems that will neutralize the corrosive emission from the suction, right? And to prevent or minimize effect onto surrounding building. So with that, let's go to our question and answer session. And Hidayah, all right. So how far from the beach line or sea line should the building to be considered free from seawater effect? All right. So this is actually an excellent question. So in fact, for building to be located near the sea, there is actually a distance where we consider it to be within the sea influence. So it depends on what kind of matrix you use. So typically there's a standard where we measure certain chemicals, right, in the air, or what we call precipitation in the air, that consider it as a marine environment zone. So the standard, if I'm not wrong, is called ISO 9223. But of course, for our from BlueScope, we actually would consider, from Malaysia context, right, 1 km from the sea will be considered within marine influence. Of course, a different location or different country, they might consider it differently. Okay, but in say certain documents, for example, our public works document, they might consider 5 km within the sea line to be considered as marine influence. So it depends on the guideline. But what I would say is, as long as within 1 km, you could safely say that it will be within the sea influence, and then you should consider a more precaution to actually prolong your building lifespan. So the second question, can I use stainless steel fastener to avoid premature corroded fastener for steel cladding? Okay, so just now I presented on seawater influence, right? To actually prevent steel fasteners from rusting prematurely, right? Due to the salt accumulation. Then there is, one of the ways is actually use a concealed fixed profile, meaning there won't be any types of external fastening. So there is also another way. Sometimes people will consider, hey, how about stainless steel fasteners? Would it be suitable to be used, right? So currently, based on our experience and observation, stainless steel fasteners in those environments would cause premature corrosion. If let's say it's a typical type of stainless steel fastener without any additional component, right? The reason is because the stainless steel fasteners would be, once it's fastened onto the profile, it would be in direct contact with the steel cladding. And this will cause what I call a galvanic reaction, because stainless steel paired with zinc, paired with aluminum or steel, it will actually cause a reaction, same like copper with steel that we covered previously in the previous Steel Connect webinar. So to prevent this, stainless steel, if let's say you absolutely want to use stainless steel, then there is still a way by isolating the stainless steel from the fasteners. Meaning, if let's say the stainless steel provider or manufacturer can have a separation sleeve that would ensure that there's no direct contact with the steel cladding, then it is safe to be used. But so far, based on our observation, there is not much of existing options that is in the market. Okay. We to give you a bit of context, we actually observed this being used in some other countries like South Africa, but it's also not very common. So the option is not much over there. But it's worth to explore. Okay. If let's say we have our any fasteners manufacturers out there, perhaps you can think of something for this environment. So moving on to the next question. Normally, how soon sign of premature corrosion will occur at unwashed area of cladding? What should we do if sign of corrosion occurs? Okay, so again, actually the unwashed area I covered today will be on the seawater, right, where the sea breeze bringing out all these salt particles and accumulating on all these areas. But in fact, it does not just occur on the seawater, but it is commonly seen for also indoor and also the indoor pool and also the glove factories, where basically whatever is within the building is considered unwashed area. So how soon of premature corrosion would you observe on this unwashed area depends on how fast of these corrosive deposits settling onto the surface. Okay, so to give you a bit of context, if let's say the building or the unwashed area is in South Africa, for example, compared to in Malaysia. We know that South Africa, the seawater is much more saltier. Okay, so the salt accumulation on this unwashed area in South Africa would be much more faster compared to here. And I would not be able to tell you how fast, compared to different environment, you will see premature corrosion. But different environment could show you, the effect differently, right? Depends on different timeline. And another effect that would actually affect the premature corrosion timeline is the choice of material. Okay, so that's why just now I highlighted that it is actually absolutely crucial for you to choose a durable material that has been proven to last in those environments. The reason why is because most often this is neglected by designers because of, I would say, priority on perhaps cost, right? Or maybe supply availability. So the downside of that is that your building could encounter could be exposed to all this salt accumulation, and over time present a safety risk. I would say nowadays we see there is extreme weather in all kinds of country, and one of the detriment of that is that the roofing sheets could fly off and hit some other building, or worse off, a human, right? So by using a more durable material, what you are preventing is, the metal sheets flying off, and of course, again, to provide you a long-term solution for your building. I think for designers, maybe, or for QS, if let's say there's any today, you can consider the risk factor of using a cheap material or so-called low-cost material, but factor in the safety risk as well as the replacement cost, because those I would safely guarantee you it will cost you more because of the workmanship, because of the risk. It's not worth it. So yeah, so I hope that covers. So to summarize that question, premature corrosion, how fast you will see it depends on the environment and depends on the material you use, how durable it is. Okay, so how should you prevent it? Is actually just now I mentioned, to have a wash down to dilute the salt particles. Okay, and if let's say on the early stage of design, perhaps you can also introduce what you call a non-reactive barrier to limit the exposure of all these vulnerable components from unwashed area. So next question, based on previous projects or experience, which country have the highest salt concentration in which in Malaysia means which state? Okay, of course, if let's say which you are considering Malaysia, which state would have the highest salt concentration or salt build up, then it will be depending on the sea condition or the beach condition, right? So for Peninsula, the so-called the west coast, meaning along the Penang, Malacca, Johor, including Selangor, this area is shielded by our neighbor Indonesia, so the sea breeze will be less strong, so it will be the least corrosive compared to the so the east coast like Kelantan and so on. Then the east coast, definitely because of the South China Sea, or the South China Sea basically. So the ombak will be stronger, and the more corrosive one will be on the Sarawak and Sabah side, because you can look at the map. It is facing a huge, larger ocean mass. So that's why the sea breeze will be stronger then. So we will expect those areas would have a higher tendency of salt concentration of salt build up. And it is more crucial for you to actually consider all these design factors. Okay, so moving on to our next question, could you elaborate further regarding non-reactive barrier, and so far how long lasting this building material in indoor swimming pool or glove factories? Okay, so to elaborate on the non-reactive barriers, the reason why I put it in such generic term is because currently they are not a standard practice to include this component into the building, right? But one of the more common one would be aluminum foil, but based on my expectation, aluminum foil is still a metal, right? So it will still react with these so-called chloramine or so-called corrosive chlorine substances. So when I say non-reactive, it means that in contact with all these chloramine or chloride substances, it should not have any galvanic reaction and so on. So something that is non-metal would be great. And how long it lasts actually depends on the barrier that you use, right? We have actually seen certain components or certain non-metals barrier that can actually resist the chemical really well. The only downfall for those barriers would be its longevity when it's exposed to a certain temperature, right? So on the roof, normally it will expose to the heat from the sun. So if let's say it can resist such temperature around maybe 60, 70 or 80 degrees Celsius, then perhaps it can last longer. So far we have not had any records of any specific case where how long it lasts. Okay, so but we do recall there's another option, another solution that we have observed is introducing a sealing, right? So the sealing, just like any other sealing, could be made of cement board. So this cement board itself, could actually provide an initial barrier to prevent or limit all these chloramine to get in contact directly with the roofing sheets or even with the fasteners. So that is another option. And how long it lasts, we have seen one of the glove factories where this system itself, what we call system means the roof with the ceiling, was still standing for over 10 years. Okay, so there is actually pros to introduce an additional barrier, and I believe for designers or for people who are doing maintenance for this building, you should actually consider the cost benefits of not having additional replacement, and especially the labor cost, not just the material cost. I think you have to look at it holistically. What is the downtime that you would potentially have for these factories or for these buildings, right? And of course, the cost of material is fluctuating, depends on supply and demand. Okay, so if there are more questions, now is the time. If you do not have more questions, then we would conclude today's session. And of course, again, if you have more questions, you can always approach us. We are approachable through our Facebook, email, and our website. And of course, to go, if let's say you want to rewatch this session or you want to convey this message to your colleague or to your designers, then you can actually go to our YouTube page and share the video to your colleague. Okay, we have some one question here. They are saying a thicker roofing sheets will last longer. What's your comment? Okay, so okay, thicker roofing sheets will last longer. This is actually a legit comment and a legit assumption, because if let's say, for example, you have your coated steel or so-called aluminum sheets roofing, right, then it will actually allow for the corrosive substances to actually react with the material. And if let's say you increase the material to thicker material, that means more material needs to react with the chemicals to actually wear off. So it will naturally be longer compared to the one in thinner material. But you have to look at what are the reaction time or reaction speed. Okay, for example, if let's say thicker by a bit for your roofing sheets in say very corrosive environment like glove factories, then you're not seeing much benefit compared to introducing an additional barrier that is non-reactive. So you need to look at the reaction time. So adding a non-reactive barrier and make sure all the lappings are sealed could mean there is less to negligible reaction with the non-reactive barrier, and this could actually prolong your roofing sheets much more longer compared to just adding the roofing sheets to become thicker. And I would say from a structural point of view, you can also consider, because if let's say you add the thickness right to thicker, then the strength need for the structure to support those thicker material will be higher, as opposed to a non-reactive barrier that typically is I assume to be lighter in weight. Okay. So and so that's all, I think. And if let's say you have more questions, definitely just hit us up, and it's what we have so many options for you to do so. All right. So thank you for joining today's Still Connect webinar. And as always, we are happy for you guys to learn more. And thank you.